Welcome! In this session, we're going to get oriented with PyTorch. Before we dive into coding, it's important to understand what PyTorch is, why it's been so influential in machine learning and artificial intelligence, and what advantages it offers compared to other tools. By the end of this topic, you'll have a clear sense of where PyTorch fits into the AI ecosystem, and you'll be ready to set up your own environment to start experimenting. PyTorch is an open-source deep learning library created by Facebook's AI research group and first released in 2016. Even though it's relatively new compared to older frameworks like TensorFlow, PyTorch quickly rose in popularity because of its simplicity and flexibility. One of the reasons researchers love PyTorch is that it feels very natural if you're already comfortable with Python. It doesn't force you into a special programming style. Instead, you write normal Python code, and PyTorch provides the building blocks for tensors, neural networks, and automatic differentiation. Within just a few years, PyTorch became the go-to choice for academic research, and today it's widely used both in teaching and in real-world AI systems. One of the biggest reasons people prefer PyTorch is its use of what's called a dynamic computation graph. This is sometimes described as a define-by-run approach. What this means is that the model's computation graph is built as your Python code executes, rather than being predefined before you run it. This makes debugging and experimentation much easier. If you want to insert a print statement, use an if-else branch, or change a loop, you can do so directly in Python, and PyTorch adapts. Another strength is seamless GPU acceleration. If you have a compatible NVIDIA GPU, PyTorch can move tensors and models to the GPU with a single command, giving you a big speed-up in training. PyTorch also integrates very well with NumPy, so you can switch back and forth between scientific computing and deep learning without friction. Finally, PyTorch has a strong community. Because so many researchers use it, there are countless tutorials, libraries, and extensions built on top of PyTorch that you can leverage. Another thing that makes PyTorch powerful is its ecosystem of companion libraries. For example, TorchVision provides standard datasets like MNIST and CFAR10, as well as common neural network architectures such as ResNet or VGG. This saves you a lot of setup time if you want to experiment with vision problems. Torch Audio does something similar for audio processing, and TorchText supports natural language processing tasks. Beyond the official libraries, PyTorch also has third-party frameworks that make development easier. PyTorch Lightning helps organize code so that your experiments are cleaner and less error-prone. Hugging Face Transformers provides thousands of pre-trained models for natural language tasks. And Fast.ai is a high-level library that makes training deep learning models even more beginner-friendly. All of this means PyTorch isn't just a single library. It's part of a rich ecosystem designed to support many different AI applications. When learning PyTorch, it's natural to wonder how it compares to TensorFlow, which was the dominant deep learning framework before PyTorch emerged. TensorFlow was originally built with static computation graphs, which could be harder to debug, although more recent versions of TensorFlow now include eager execution similar to PyTorch. The main distinction is cultural. PyTorch has become the tool of choice in the research world because of its flexibility and intuitive design. TensorFlow, on the other hand, remains very strong in production environments. It has tools like TensorFlow Lite for mobile devices and TensorFlow Serving for deployment at scale. In this session, our focus will be entirely on PyTorch, learning how to build, train, and evaluate models. Later, you'll also explore TensorFlow so you can see the similarities and differences yourself. To get PyTorch, the best starting point is the official website, pytorch.org. You'll find an installation selector where you choose your operating system, package manager, Python version, and whether you want the CPU version or the GPU version. The CPU version runs on any computer and is perfect if you don't have a powerful machine. The GPU version lets PyTorch use your graphics card to speed things up, but it requires an NVIDIA GPU and something called CUDA. That's NVIDIA's toolkit for running computations on the GPU. Remember, CUDA is optional. If you don't have a GPU, you can still use PyTorch just fine with the CPU version. Now, about installing. You'll often see two tools mentioned, pip and conda. Pip is Python's built-in package installer. It comes with Python and is the most common way to install libraries. Conda is another package manager that comes with Anaconda, a popular distribution of Python for data science. Both do the same basic job. They download and install PyTorch for you. If you're using standard Python, pip is usually easiest. If you're working in Anaconda, then conda might be more convenient. When installing PyTorch, always go to the official website. Under the section called Start Locally, you'll see a menu where you select your operating system, package type, programming language, and compute platform. The site will then generate the exact command you need to run in your terminal. The most common choice is pip for the package, Python for the language, and CPU if you don't have a GPU. If you do have an NVIDIA GPU, you can choose CUDA for faster training. Keep in mind that the website changes over time. Version numbers and the exact menu design may look different when you visit, but the process is the same. Always trust the official pytorch.org site to give you the right instructions for your setup. Once you've installed PyTorch, it's a good idea to test that it works. Step 1. Open a Python shell or Jupyter notebook and type import torch. If there are no errors, PyTorch is installed correctly. Step 2. Check the version by typing torch.__version__. This command will display the installed PyTorch version. Step 3. Check whether your system can use a GPU. For that, type torch.cuda.is_available with parentheses at the end. If it prints the word true, that means PyTorch can see your GPU. If it prints false, that's fine too. It just means you'll be using the CPU. Now that you know how to install PyTorch, let's look at why it's such an important framework. PyTorch is everywhere in the artificial intelligence world. In computer vision, PyTorch powers models for tasks like image classification, recognizing whether a picture contains a cat or a dog, and object detection, identifying where in an image the objects are. In natural language processing, PyTorch is behind many chatbots, text translators, and summarizers that can read, understand, and generate human language. In reinforcement learning, it's used to train robots to move and interact with the real world, or to build game-playing AI that can compete at a superhuman level. And beyond research, PyTorch is being used in industry. In healthcare, it helps analyze medical scans. In finance, it supports fraud detection. And in the auto industry, it powers the perception systems of self-driving cars. So, when you learn PyTorch, you're not just learning an academic tool. You're gaining a skill that is valuable in both research and real-world applications. Let's wrap up this introduction to PyTorch. PyTorch is a deep learning framework that is designed to feel natural for Python developers. It uses a dynamic computation graph, which makes it flexible and easy to debug. Its strong ecosystem, with libraries like Torch Vision and Torch Text, supports a wide range of applications. PyTorch is not just a research tool. It is also widely used in industry, in areas ranging from healthcare to finance to autonomous vehicles. In the next topic, we'll move on to tensors in PyTorch. Tensors are the fundamental data structure. They're how PyTorch represents numbers, images, and even text. Understanding tensors is the foundation for everything else you'll do with PyTorch.